Hi, this is the host. When you're as tall as a giraffe, everything is harder. Walking long distances, finding a mate, getting a drink of water, and staying upright when it feels like gravity is trying to pull you down at an accelerated rate. But giraffes seem to take all of that in stride. How do they do it? They look like they're made of twigs and string and held together with hope and duct tape. So how do they not fall over? Well, some recent research says it's all about their ankles. A new study published in the journal Royal Society Open Science used X-rays and 3D imaging to look at the bones and joints of a giraffe's legs. They were particularly interested in the distal end of the giraffe's tibia, also known as the ankle, which makes up about a fifth of the animal's total height. The researchers wanted to know how the structure of these bones and joints helps giraffes walk without falling over. And what they found was pretty surprising. It turns out that while the bones themselves are relatively lightweight, they're also super strong thanks to the way they're structured. See, bones have a spongy center and a hard outer shell, and the inside of the shell has these little holes that help reduce the weight of the bone without sacrificing too much strength. And while those features are pretty common among mammals, scientists were surprised to find that the spongy tissue inside the giraffe's ankle bones was arranged in a way that made them even stronger than they expected. That tissue is called trabecular bone, and it looks like a bunch of tiny arches supporting a flat surface. And while other mammals have this kind of spongy bone in their ankles, the pattern in giraffes is more like the trabecular bone in the vertebrae of mammals, which are adapted to withstand heavy loads. This suggests that the giraffe's ankles experience a lot of pressure, likely because of the immense weight of their upper body pulling on their legs. But there's more to the story. Those long, slender legs are also full of tough, fibrous tissue and collagen, which helps keep the bones from bending or snapping under pressure. It's kind of like those cheap plastic dinosaurs we had as kids. Their limbs were basically just thin, hollow tubes, but they were almost impossible to break. Now, obviously, a giraffe's leg is much more complex than a dinosaur leg, but this basic material property helps us understand why giraffes don't collapse like a house of cards. And based on this new research, scientists think there may be a few other factors at play, too. First, giraffes have relatively small feet, which helps them balance. Kind of like when you're walking on a beam. Having a smaller base of support makes it harder to topple over. But giraffes seem to get extra stability from their ankle joints, which have a lot of interlocking bones and ligaments. In fact, the researchers say the amount of movement in a giraffe's ankle joint is similar to what you see in the knees of quadrupeds like dogs and horses, which are built for running. But unlike those animals, giraffes don't really run. So why do they have these knee-like ankles? Well, scientists think it might have something to do with their evolutionary history. Like most mammals, giraffes are descended from four-legged ancestors, and somewhere along the way, their lineage started walking on two legs, eventually giving rise to the awkward yet majestic giraffe we know today. But the researchers say the features in a giraffe's ankle might actually be a holdover from their four-legged past. Basically, they kept the ankle structure that helped them balance when they were quadruped, while evolving into the tall, thin creatures that we know today. So thanks to their super strong yet lightweight bones, their flexible collagen fibers, and their small feet, giraffes are able to stand upright and take steps up to 6 feet long without falling over. And that's pretty graceful if you ask me. And thank you for watching.